In this video, I'm going to show you how you can use Amazon Web Services, Elastic MapReduce, and Hive to filter data for importing into SAP HANA One for additional analysis. Let me just go over again our solution overview for what we're doing with the Wikipedia data. In our prior video, showed you how you can take the data that comes from Wikipedia and the hourly dumps that they have and use an Umberto server as a copier mechanism to get the data into our S3 storage. This particular video will focus on using Elastic MapReduce and Hive and the S3 storage to prepare our data for importing into SAP HANA. So let's begin. In order to use Hive against our data in our S3 bucket, what we need to do is create an Elastic MapReduce cluster to do the processing. Now I've assumed that you've already logged in to your account that you're going to be using and it's in the correct data center. And so what we're going to do is go ahead now and click on Elastic MapReduce. Now here you can see I have several jobs that have worked in the past, and I'll talk a little bit about this failed job that you see right here a little later. But right now what I'm going to do is click on Create a New Job Flow. I'll give it a useful name. Hive Demo. I'll choose to use the default distribution for Hadoop. And what I'm going to do is select Create Your Own Application. You have the ability to run sample apps just out of the box to see what's going on with the system, but what I'm going to do is I'm going to select Hive program, and what this will do is set up our Hadoop cluster with Elastic MapReduce to run Hive and have everything pre-installed for us. So I'll hit continue here. Now there are two ways you can run Hive jobs. One is as a script, in which case you specify a script location and where you want your input and output directories. And what will happen is that once the job will kick off, execute, and then terminate everything after everything is done. Now if you're experimenting with Hive like we are, what you want to do is use an interactive session, and here you'll connect through a console, an SSH console, and we'll use the Amazon one for this, to actually do our operations in a console. So I'll click continue. Okay, this is probably one of the more interesting dialogues here, because what you want to do is define what you want for your head node or your master node for your Hadoop cluster. And this doesn't have to be the beefiest machine, but it is the one that does all the compilations and distributing of tasks and scheduling of tasks. So it needs to have a little horsepower, but the small instance is plenty for us. The other thing you need to do is specify what you want to run your tasks on. And again, you want to structure the size of these and the number of them based on the tasks that you're performing. Now in our case, I'm going to want to use 8 instances here of the small instance. Now I should point out that there is this option to request spot pricing, in which you can give it a bid price to do your estimate to run your servers. Now before you do this, what you want to do is make sure that your bid price is in line with normal instances. For example, if I go and look at the Amazon pricing page, what I'm looking here is typical spot instance prices on average for this particular instance. So for example, in the small instance, I can actually get a machine for as cheap as 0.7 penny per hour to run my job. But here's the catch. If someone needs these instances and bids a higher price, I can lose my instances to that other person based on the bid. So I either have to work really, really fast or make sure I bid appropriately. Now the way you can tell the prices is by actually going over to, let's go bring up our cluster here. So you can see here back to what I was talking about is that I had a cluster previously set up where my instances that I requested using the spot instance at 3 cents an hour were actually outbid by someone else, and I lost those instances and terminated the cluster. So if I go click on pricing history, here's where I can select the product, and it uses Linux here as the main thing, and you can see someone decided to go ahead and order a lot of machines at $1 an hour for this M1 small instance. Well, do you really want to spend $1 an hour if you look at the pricing information here is that you can run ad hoc instances on your system here. So here's the on-demand prices. And you can see here, essentially for a small instance, the going price that you can pretty much guarantee that you get an instance is $6 an hour. And so what's happening is someone has gone ahead and bid a dollar per hour, which basically is, the same price as this double extra large second generation on-demand instance. So, it's a question of economics. So what I'm going to do is rather than do a spot instance, I'm going to use a standard instance for my job. So again, I'm not going to use a spot instance. But again, if you're running during the weekend when there isn't a lot of activity, spot instances may be a good choice for you. So go ahead and hit continue here. Okay, the next thing it's asking for is an EC2 key pair. And again, if you're running a script as part of the automated process with parameters, you don't need the EC2 key. This is basically going to be used for your SSH client when you're connecting to your Hadoop head node. So in this case, because we're doing an interactive client, we're going to have to specify our key. We don't specify our VPC. This is a virtual network that we can actually set up to our own data center if we needed to talk back and forth between Amazon. We're not doing that. I could also specify a log path to keep track of what's going on with my Hadoop cluster, but I'm going to assume everything works just fine on my Elastic MapReduce cluster. So I'm going to leave the path empty and not enable debugging. So I'll go ahead and continue. In addition, for advanced scenarios, if you know what you're doing, you can specify additional parameters that run when you set up your cluster so that this can all be automated for you. Examples might be setting up, installing Oozie, which is a workflow manager to coordinate jobs and be able to chain MapReduce jobs together. You could go ahead and specify that you'd want to have Oozie installed as part of your process flow automatically to do whatever you had specified in your initial parameter set. In our case, we're just doing an interactive session. We'll take Hive out of the box as it stands and go ahead and continue. We now get a confirmation of job flow name, our instances, the count that we're going to have, our key pair, and at this point, I'll go ahead and create the job flow. So the job flow has been created, and you can go ahead and click on this link to take you to what's going on. Now, when you first create the job flow, what it does is it starts this process where it runs these steps to install Hive once the cluster gets set up and run the script to tell it to use the latest Hive version. In addition, it creates these instance groups that are used to define the master and slave instances. Now, when your Hadoop cluster gets up and running, the state will change to working so that you know everything is ready to go. The other way to know is when your cluster gets set up is you'll get a master DNS name, and this will be the IP address that you'll use for connecting to your Hadoop cluster. Now, behind the scenes, what's happening is this is creating essentially 9 EC2 small instances in our system. So if I go now over to our, let me go ahead and close this dialog and go to our instances here and do a refresh. What's happening now is that we're kind of waiting for our instances to spin up. And so what will happen is that once our machines are up and running, they'll show up here in our instance pool. So what we're going to have to do now is wait for Amazon to complete the instance requests, and then we'll come back and actually log into our Hadoop cluster. So at this point, what I'm going to do is I'm going to go back over to our Elastic MapReduce console. Just do a quick refresh to see if anything's changed. And so what we're doing now is just waiting for our instances to be defined. Okay, if we look now back at our system, you'll see you've got a whole bunch of instances that have been created in our behalf, of which we have 1, 2, 3, 4, 5, 6, 7, 8, 9. All of the instances are up and running. I'm going to take a look at this particular instance here and kind of scroll at my display and show you that the instance that I selected is our Elastic MapReduce master instance. And this is the one that we actually use to connect to our cluster once we verify that it's all up and running. And so if we look here, we'll keep this in mind. And what I want to do is just to remind myself, I could tell kind of by the instance name that it was a little different, but you can also tell by the security group type, which is this field value here. If I expand this out, I can see that was the master. I'm going to, just for simplicity's sake, what I'm going to do is change the name of this instance just to keep track of the master for it. So I'll go in and type in master and save that off. And at this point, what I'll do now is go back to our EMR cluster, and you'll see now that the status of the cluster is designated as running. And when I go ahead and select this now, you'll see that my master DNS name, this is the same one that I have over in our EMR, on our EC2 console, right over here. So what we're going to do is connect to this particular instance right here and go ahead and start using the Hive Interactive Console within our Hadoop cluster. Okay, to do that, what I'll do is right-click on the instance and say Connect. Now, by default, because I've connected several times to this instance, it's using the private key path, my HANA Havana .pem file, for access to the system. But the one thing you should know is that the Hadoop cluster that's created as part of the head node for this Elastic MapReduce Hadoop cluster actually needs to use the username Hadoop when you actually connect to the system. So what I'm going to do is go ahead and hit launch as my client here. And at this point, I now have my console in which I can now perform operations. Okay, so to start Hive, it's very simple. I type in the command Hive, and this is a command line interface where I can actually type in the name of a startup file or the executable that, or the command file that has a SQL statement in it or whatever. But again, since this is a demo and I want you to kind of learn how things work on the fly, I'm going to go ahead and use the interactive console. To get out of the interactive console, this took me a little while to figure out. There's a quick command, and more importantly, every command terminates with a semicolon. If you forget the semicolon, it's going to keep on giving you a Hive command or a Hive prompt. So that's just a quick and dirty thing. Always remember the semicolon at the end of your commands, and then the quick command will get you out of the system. So now that we're in, we can verify that it's using Hive, the 0.8 release, so that when you're looking at the language reference for Hive, up on the Hive wiki, any language features that are greater than 8.1 are not enabled in that particular build. Okay, so first thing we're going to do is we need to create a table that matches our data format for purposes of loading in the data into Hive. And what we're going to do is issue a create table statement that will do just that. So what I'm going to do is, I've got my little clipboard reference here, and I'm going to paste in the command. What we're going to do is tell Hive to create an external table. And external is important because what this says is that the data for the Hive table will actually be persisted outside of the Hive data warehouse. There's actually, If you don't do that, what will happen is data will actually get moved into the warehouse, and so using our S3 storage, the data would actually get moved out of there into the Hive console, and then as soon as we destroyed the cluster, the data would be gone. And so we're telling it to create an external table, very similar to SQL syntax. It creates a table. You have your columns and your data types. Here they're kind of loosely coupled data types, so we don't have to specify the length of a string parameter, for example, but string would be similar to varchar. And then we have you have a big int versus int data type that will capture the data for our hits. We're also using a partition syntax. If you recall in our S3 browser, so let me bring up our S3 folder here. What we're doing is we're telling it within our bucket, under our Wikipedia page counts data, this is the place where we loaded our data from Wikipedia. So if we look at month, so here we have these folders for day, for year, month, day, and hour, right? And what this does is allows Hive, when it's reading in the data, it'll actually rip through all the directories from the root path where we have, in this case, Wikipedia page counts, and partition the data based on the name of our directory values. What this means is you can load in the data from the GZ file that we have right here. And the GZ file doesn't have values for year, month, day, and hour. And we had our shell script that previously put it into the appropriate directory. And so what this means is that the values for year, month, day, and hour will come from these partition values. So with that, we can tell it to partition by year, month, day, and hour. And we just have to make sure that the directories are set up as year equals, month equals, day equals, and so on. So this allows you to organize your data and have Hive automatically pick up and add the data associated with that based on your directory structure. Now our data is delimited by a space, and so we're using the /32 to represent the space character, and then we have our location value where we're going to do our results. So with that, we'll go ahead and execute this command. Now we're not actually loading any data. What we're doing is we're telling Hive to build a table on top of our structure that will be ready to load in our Wikipedia data. I'll let this go a little bit. Okay, to validate that the Hive table is there, we can actually use the show tables command. So if you create multiple tables within your Hive cluster, you can see them through the show tables command. You can also say describe, DESC, shorthand DESC, and then specify your table, page counts, and again the semicolon. And so you can see here that the page count files has a project code, project name, or page name, and so on. And then here you see what look like columns in the table that are actually partitions as year, month, day, and hour. Okay. Next thing to do is we need to tell Hive that the data is actually stored in specific partitions. And the way that we do that is through the alter table command. It looks like this. Okay, so we'll go to our console and we hit paste. There's our command. Okay, and what we're doing is we're saying for the table, add the partition year equals, month equals, day equals. Now in our case, since we're doing May data, I'm going to go back here and change this to a 5 for May. What this will do is go ahead and look for that particular partition. In this case, over in this S3 bucket, what it's done is it said, okay, this is our first partition where we're going to find our data. And so if I look at the show partitions command now, so I'll go over here and paste this in. You'll see we have the one partition. Now at this point, Hive only knows about this particular directory of data. if we were to perform any operations. To get Hive to represent everything under this directory structure, we use what's called the alter table page counts command with the recover partitions clause, which looks like this. And what this does is it will go through all of our directories within our S3 bucket and start defining partitions that are associated with the data in those directories. And this will allow us to do queries on top of all the data that we had. In this case, we've got data loaded up for the months of March, April, and May. So this is going to take a little bit. I'm going to stop the recording for a bit, and we'll come back in about a minute and see the results. Okay, we're back from the recover partitions command, so it took a little longer than the minute. But what this does now is essentially, although the data is not actually loaded into the Hive table, it's now available for processing. Now what we can do is actually use a command called show partitions against the table to see all the different partitions that it did create. And so if I go in here and do a paste, I should point out that the interactive console is a little sensitive to how you do copy and paste, and so if I don't do it right, it clears out my copy buffer. But the way to do it was when you get the dark blue square here, if you go immediately to edit and paste, it should work. So we'll go ahead and run the show partitions clause, and you'll see here is that we see all our different partitions for May, and if my command buffer was, if I had more, I'd see March and April in here, so this is just showing the end of it. And now at this point, all our data is kind of registered, and now we can start doing some interesting queries. So the first query I'm going to do is just give you an idea of kind of how much data that we have in here, and so we'll go ahead and now paste into our console, and I'm going to just do a count for 1 hour at this point. And again, put my semicolon in here. And so what this is doing is now doing a count for where year equals 2013, month equals 5 for May, first day, and then the midnight hour Greenwich Mean Time. And you'll notice the select statement is just looks like standard SQL. So we'll go ahead and let this process. So what's happening here is that the system, because we're only processing in one particular hour, it determined that we only needed one mapper, and so it's going ahead and it's compiling the code, checking to see kind of where it's going to get the data from, and then it's going to send out the map task and then the reducer task as needed. In this case, we won't actually have any reducers, but actually I might be wrong. We have one reducer. Typically you find reducers when you do commands like count star or group by clauses and things like that. They'll force a reducer. But again, since we're only dealing with one particular partition in the table, it only said, hey, I'm going to just use one mapper and one reducer. So we'll let this run through. It shouldn't take too long. One thing I should point out while we're waiting for the command to finish is that for each time you run one of these MapReduce jobs, there's an associated kill command that goes with that right here. And what this allows you to do is by running this particular Hadoop job and this command right here, it will kill a long-running task. If, for example, you should find that you did a rogue query or something like that. So we can see here our mapper and reducer have completed, and for this particular hour, to get an idea how much data that we're using, we have over 7 million records that were consumed. So what would do to limit that, rather than load all this 7 million rows of data into HANA for processing, we'll just use a little bit of statistical thought here and say, okay, rather than load all those data, all the data in there, for even including trivial files that may have less than 100 hits or so, we're going to say, let's just take the data that has 100 or more page hits in there. And so what we'll do is, rather than, again, loading the 7 million, that's for 1 hour, multiply that by 24 hours and then by the number of days in the month. You can see that the data for a month, can easily grow well beyond the capability or the storage requirement for AWS HANA One. Specifically, we did a quick computation that when I uncompressed all the files, because you got to remember the database has on disk to store all the data in an uncompressed form. And what will happen is that I'll only be able to have a limited amount of data. And this, my drive is set up on AWS HANA One for 190 gigabytes of data to fit within the 64 gigabytes of memory that is on the HANA One instance. I computed on the back of the napkin and realized that I needed a drive size for just 1 month of about 350 gigabytes. So rather than create an extra drive and hope that all the compression algorithms work and all that, I said, okay, let's limit the data that we do. Rather than having all the data, let's do something that captures more of the interesting data. So by doing that, what I said is, okay, let's do instead just bring in the data where hits per hour is greater than 99. So to give you an idea of what the reduction means on that, we'll go ahead and let this query run now. Okay, so it started our MapReduce process, again with the kill command. Sometimes I find if I just copy that to the clipboard, paste it in a notepad, that's useful. This is especially interesting to know that command to kill things, because what will occasionally happen is that the SSH client here on Amazon, if you don't watch out and you close this thing down, the job will continue to run. It's just sometimes hard to figure out what it was that was running when you look at, say, the top command to see the process IDs that are running, because it all looks like it's under the Hadoop job, so you're not quite sure what it is that's running at any given time. And so that's why it's kind of useful to copy and paste that command into like Notepad or something like that, so you can keep track of what's going on. Okay, so we're starting on our reduction. Again, this is taking all the little sums of data that the mapper took and then doing the count on the values. And so here you see we've got it down to 14,509 values that had page counts for that hour that were greater than 99 hits. Okay, so now that we have an idea of how many records that we're dealing with per hour, we're now going to have to we're now going to do a process to check out kind of what the data looks like. And so what I'm going to do now is show how you can create an output file from a query. So what we're going to do is go ahead and run the select statement, which says select project code, page name, year, month, day, hour, hits per hour, where our year equals 2013, month equals 5, day equals 1, and hour equals 0, 0. And what we're going to do is insert that into a directory right here for our May data. Now it's very important that you realize that this is called insert overwrite directory. So if you have anything that's under this directory will get overwritten. I learned the hard way on how that works, and so you always want to make sure that you don't have any data in there to begin with. So here you see I don't have my May 2013 directory, but it will get created after I run this command. So let me go ahead and run this command. Now you'll see here that it creates a total of 2 MapReduce jobs. The first MapReduce job, what it does is it actually goes out and does essentially that initial mapping of the data. It's gathering up, it's doing the select processing. The second reduce job is the one that will actually take the data and place it into the directory structure. And so let's watch how the next 2 phases work out. Okay, so now we're processing the first MapReduce job and now getting ready to do the data, writing the data out to the directory. Okay, our Hive job is now complete, and you'll see here that in our S3 bucket, if I was to go ahead and refresh this, we now have a May folder, and there's one file in here with that's named with 6 zeros. So what will happen is that based on the amount of output results, Hive will automatically break up this file into separate chunks that tend to be around 250 megabytes a chunk. So here we're well under that size range here. But if you notice now, we get a confirmation that we loaded in right here the same number of rows that our count command gave us. So that means everything worked as expected. Okay, so showed you how we can do a quick test. Now the next thing I want to do is, rather than bouncing back between windows, for example, I just happen to have an S3 console open, you can actually run Hadoop file command or Hadoop file cluster commands in Hive, so that you don't have to bounce out back and forth between your Hadoop cluster and your Hive console to do work. And so, for example, if what I wanted to do here is show the output of the results using the distributed file system, or could be sometimes known as HDFS, but in Hive the command's called DFS. I can do an ls command, which is for doing the same thing as a directory or a listing of the items here for my S3 bucket, as if it was a mounted drive on my system. And if I hit enter here, you'll see here's my one bucket. Likewise, you have the tail command available. So if we go ahead and do a DFS command and use the -tail option, we can actually see the last bit of results. Now you'll notice here in the results list is that the data is actually between our field values, our column values, is delimited by this Control A character. Okay, so right here, the first thing that that you see here is the project code, and so this is for the ZH language, and the project is .mw. Now for just plain old Wikipedia pages, there is no dot. If you don't see a dot after the first code, means it's part of the Wikipedia page for that language. And then, for example, under special search, you'll see here, this is the actual page name. Then we have our Control A, and then we have our year, our month, day, and hour, along with our, these are the page hits, and then these were the bytes downloaded for the number of page hits for that. So that's how the file is delimited. Now, what we're going to eventually do before we load this into HANA is we're going to have to replace these Control A characters with the pipe symbol, but I'll show that in a future video, and that's actually something that you'll get to do with the hands-on lab that we're creating. So if I go back now to our Hive prompt, I'm now ready to actually do a full run for the month of May. Now I can repeat my commands within the console by using the up arrow key. And here's our insert overwrite directory command. And what I'm going to do now is I'm going to keep the clause and hits per hour, but I'm going to get rid of the clauses for hour and day. And so what this will do is go ahead and do the full run over our data. Again, somewhere around 350 gigabytes of uncompressed data, to then take our output results and overwrite them into our directory over here. So what I'm going to do is go ahead and start this process off and make sure that it actually compiles. Now it takes a little while for the engine to compile this. It's going through and doing the partitioning act to see how the data is partitioned, and then trying to figure out how many mappers and reducers to do. So the first thing it realizes that, oh, I've got two separate commands, and I'll break that out into my two separate jobs. Again, there's no reducer operation on this because there's no count or sum or group by that's involved here. So we'll go ahead and let that continue processing. And what I'm going to do is pause, and then as significant events come up during the processing, I'll show you what's going on. Okay, one thing I want to point out right away is that during this initial processing, because it's kind of setting up the overwrite directory, if we go back to our S3 console here, you'll notice now in my Wikipedia page counts Hive results bucket, the May 2013 folder that was there, or directory that was there, is now gone. And so it's already started the override action as part of the processing. So we'll go back and let this thing continue to run. Okay, so our MapReduce job is now starting to run. Again, we've got our kill command. I'm actually going to just go ahead and copy this to the clipboard again, because there's a potential that I will lose whatever is going on in here should I close the window or whatever. So I'm going to keep track of that kill command in my little clipboard window that I've got working on, just in case I need it, because this job does take a little over an hour. And so the other key thing I should point out here is that now when we look at the display here, you'll see that as the job's running, it actually, in the past for those other trivial commands, it's actually now using a bunch more mappers. I'm using 744 mappers and 0 reducers. Again, it doesn't need the reduction because there's no group by, but it's doling out the work to all 8 of my workstations that were set up in the cluster to go ahead and do the mapping portion of the exercise. So this thing is going to run for a while. We'll let it go. Again, the reason I copied the clipboard, this kill command right away, was because once it starts scrolling, it's kind of hard to stop the scrolling and for the display. So we'll let this thing go for a while, and we'll come back when everything is done. Okay, just as a checkpoint here, we're still in our first phase of the MapReduce job. You'll see here that we're 23% complete. So we'll continue to let this run and keep you posted as it continues to go. Okay, just to check back, we're now at 82% of the stage 1. So as soon as the next interesting thing comes along, we'll start the recording back up. Okay, as we can see, phase 1 is now complete. And you can see just by the results of the total cumulative CPU time, essentially what this is saying is, with 8 servers working, took a little over an hour for the processing. And so now we're starting up job 2, which doesn't take as long. And so you can see here you have less mappers, because essentially it's doing 1 mapper per file that's going to get outputted. And so we'll go ahead and let this run for a little bit and come back after it's done. Okay, we're now in the final stages of the MapReduce effort, where phase 2 is wrapping up. The way we can kind of tell is that if we go back over to our S3 bucket, we now have our directory set up and our 3 files as expected. You can also see the number of rows that were loaded into the system. And so here we can see that roughly we're looking at 11,794,186 rows that were loaded in by taking, again, the query, looked at any page hits that were greater than 99 hits, and then processed that into these 3 files. And again, as we had before, we can go ahead and use the DFS command to see the results. So we'll go in here and paste our command in here. And so again, you can see the same thing that you see over here on the S3 side. And then likewise, we can use the tail command. Again, it's very important to use the tail command. There is a cat command available for typing out the file, but beware. Cat is not something you typically want to use on data related to big data, because you could end up with a lot more data than you ever intended. So let's take a look at the tail end of our first file, and you can see again we have our Control A delimited files. I hope you enjoyed this presentation on using AWS Elastic MapReduce and Hive to create input files from our Wikipedia data that we'll later use to load into SAP HANA and do analysis with Lumira. Thank you very much, and hope you enjoy the rest of the series.